So hello everyone, let's see how to think through a tree problem. So this is March Leetcoding Challenge 2021, day 9. This is add one row to the tree problem. So what's the problem? The problem is given the root of binary, then value v and depth d. You need to add a row of nodes with value v at given depth d. Root node is at depth 1. So here is the rule. Given a positive integer depth d for each not null tree nodes n in depth d minus 1. Create true tree nodes with value v as n's left subtree and right subtree root. And n's original left subtree should be left subtree of new left subtree root. So for example, I want to add the value 1 at depth d2. So this is 1, this is 2 depth. So I want to add 1 to through here. So 1 and this tree 2 3 1, this tree will be left of the 1 and this tree will be right of the this one. So this tree will be right of the 1. So if depth d is 1, that means there is no depth at d minus 1 at all. Then create a tree with value v as new root of the whole original tree, and original tree is new root's left subtree. So for example, I want to add depth is 1, then here 1, then left subtree 4, then this tree right will be empty, none. Okay, so this is the problem. Now by reading the problem we can understand that it is a breadth first search, breadth first traversal. So let's implement first breadth first traversal. So for that we need a queue. So q equal dq, q dot append root, and while q length equals len of q. So for I in range length, that is length of the level. So loop will traverse at 2 point if it is 2 node in the level. So node equals q dot pop. Okay, so we have one node. If node dot left add left node, if node dot right node, then append right node. Okay, so this is breadth first traversal. So let's print node dot value. Okay, so if we run this program, so it is breadth first traversal 4 2 6 3 1 5, 4 2 6 3 1 5. So we have to just add few things here. So according to problem, if you want to add any row at particular depth, here it is 2, then we have to traverse through only d minus 1. So here traverse through only one level and then add this value to the left and the left subtree to that value. So that is one part, and same for the right one. So add 1 to the right, then 3 to the right. So that is one step. So we have to add a condition to only traverse through d minus 1 level. So let's take a variable outside so that we can track the depth. So let's say depth equal 1 because we have already added a root. So if q and depth is less than d minus 1, so we have to traverse only one level above the adding level. So we will travel only this depth. Let's check. So it is 2 and we have traveled only 4. So that's why if we take 3, so it will travel through 4 to 6. 4 2 6 3 1 5. This one. So let's move forward. So here we haven't added depth, that's why. Plus equal 1. Okay, so this 4 and this 2 6 is in the queue, so it's not printed here. Okay, so this is depth first traversal. Breadth, sorry. So what we have to add here? So now we are traversing only required level, so till here. So we have to process that node in the queue. So let's do that. So this loop is ended. Now we have to process every element in the queue. So while queue node equal queue dot pop left. So we have a node. Now add new node. New node equal tree node, and the value of the tree node is v, this value, and the left subtree of the tree is node dot left and right is none. So default right is none. So this is our new node. Now update node dot left equal new node. So that's all for the left node. Now we have to do same for the right node. So new right node equals tree node value. Now left node is none, so we can take this value off, so we have to add none. Then right node is node dot right. Okay, so implement the node equal new right node. So that's all. Now return root. So this is our answer. So it is correct, but we haven't implemented this condition. If depth d is 1, then what? So there is only one situation, so we can add the if condition here. If depth is 1, then return new tree node with value v, and left subtree of the tree is the original tree, so root. So this is all. Now let's check 3. Yes, so let's try 1. Okay, so our answer is perfect, so let's submit it. Yes, it is accepted. So this is the answer. Thank you for watching this video.